work done. Say work done is what? Change in kinetic energy. That's a basic idea. Okay, sir, I'll do one thing. Uh, from position versus time graph, I'll get the velocity versus time graph. Then from velocity versus time graph, I'll calculate the acceleration. Then I'll multiply acceleration with mass. I'll get the force. Then I have some position. Then I'll multiply force with position. Then I'll get the work done. Can you can you think all this? Not possible, no? Can we go for alternative? Work done equal to change in kinetic energy. Do you have any information of speed here?
Yeah.
Yes, we have information of speed because in position versus
Sir,
time
the
graph. Abhigna, mute it, ma. No. From position versus time graph, what you can calculate? Slope if you calculate, you'll get the speed. And from speed, you'll get the kinetic energy. From kinetic energy, we can get the work done. Look at the slope is increasing. So speed is increasing. So from O to A, what's actually happening is, I think I'll write path. There's a path, slope, positive and increasing like this regarding the speed. Work done. Let's have a column like this here. No, first for OA, what is the slope? Slope is positive and increasing. What about the speed? Constant or increasing? Speed continuously is increasing, no?
Increasing.
Work done by the force to be positive for AB. Slope is constant, positive constant. Speed remains constant. If speed constant, no change in kinetic energy. Work done will be 0. Then here slope decreases. Path BC. Slope is positive but decreasing. So speed decreasing. Speed decreases, kinetic energy decreases. Work done negative. Till here fine. Let's come for this one. Magnitude of slope. Magnitude of slope. That's all. Because kinetic energy will not have a sign. Kinetic energy will not be negative. Will be only positive. No. Oh, okay. Now, what is the magnitude of slope? Keep on increases. So for path CD, slope is negative. Increasing. Don't look at this negative because I had to show it's the slope is negative. The object is now start moving towards left. How the motion of the object, it is like this, no? D, this is E. After C, it will start moving towards left. So in all the cases, the force was acting like this. Here no force. Here the force, it was acting like this. So call F dash F. Now the force will act here. The force will act here. And the displacement is decreasing. So here work speed is increasing, work done positive. What about DE? DE is slope negative, decreasing. Speed is decreasing, work done negative. That is what I am showing F and X like this. Okay, this is about if the new position was time graph, can we find out? Yes, we can use this method. If the give speed versus time graph, can we say anything about the work done? Quite easy, no? Speed versus time graph, because from speed, can you calculate the kinetic energy? Yes, straight away. So speed of particle increases, then remains constant, then decreases. So let this be 10, 2, 4, 5, 7. Let this be 6. This is speed versus time. Mass of the particle, let it be 2 kg. We have some information like this. What about the work done? I think it's you need not to bother anything. What was the initial speed? Initially it was at rest. No? You can see from graph itself is telling it t equals 0. What is the velocity of particle? 0. Then what happened? Speed of particle increased, became constant, then decreased, then it start increasing. So net work done. Kinetic energy positive or negative at t equal to 7 seconds. Kinetic energy is positive. Net work done will be positive. Sir, area under the graph. Shall we go for area under graph? Nothing to do, no, because what is the kinetic energy? Kinetic energy depends on just speed.
Displacement will get, sir, area under graph.
Nothing to do here, that one. So just only look at the initial speed, final speed. Final speed more than initial speed, work done positive. Final speed less than initial speed, work done negative. A student has to be very alert here. Now, sir, area under graph. Okay, we don't need any area. We don't need also slope also. Because directly kinetic energy depends on speed, no? So here, what I can say, net work done, positive or negative, will be positive. Now you have to be alert here, that's all. It's not that you don't know concept, you know. Only thing is the data given will be such that maybe confusion one. Okay, this you see this 10, or so I will take 8. Mm, 4, 6, 7, 9. Now we have some mass of the block, 2 kg. At t equal to 0, what is the speed of the block? 8 meter. At t equal to 3 seconds, speed of the block, 3 meter. So the speed got decreased. So net work done will be negative. So V9 is less than V0. V9 is how much? 3 meter. V0, okay, we'll explore, we'll write this one. Instead of this, net work done means, will there be any forces doing positive work? We are talking net work done. There may be forces doing positive work also here. Some forces doing positive work, some forces doing negative work. Net work done is negative, that's all here. Means you come for this one. Net work done is positive. There will be some forces will be doing negative work, there will be some force doing positive work. The resultant of all that algebraic sum of work done is what? We got positive. Doesn't mean that all the forces must do positive work. If you can do negative work, if you can do positive work here. The net work done is what? Positive. And now look at t equal to 0 to 5 seconds. What is work done? 0 to 5. Net work done 0 to 5 will be 0 now, because it started from rest. Again at t equal to 5 seconds, the speed is 0. Net work done is 0 here. Here net work done is 0. Here in this interval, net work done is positive. Here work done is positive. Here 0, positive. Net work done will be positive. Here it is speed, you can see that one. Constant, no work done. Negative, positive, no work done. Net work done will be negative. Okay, work energy theorem, different situations, only work done, all these things will be asked. So you have to be extra alert here, that's all. Fx graph, st graph, vt graph. If they ask you acceleration versus time graph, from at graph, what you can calculate? If they give ft graph, what you are going to do? Okay, now we have seen. Okay, sir, I'll ft graph is there, sir. From there, how to calculate the work done.